Hey physics fans, today we're going to be talking about charge and Coulomb's law. Now, back about 200 plus years ago, we found this quantity called charge. We found out that it had two distinct varieties, one being positive and one being negative. In these varieties, we found out that the charge, regardless of whether they were positive or negative, was equal to the same value. 1.602 times 10 to the negative 19 coulombs. Now, not 1.5 times 10 to the negative 19 coulombs are only integer multiples of this quantity here, meaning that charge is quantized. Also, we found out that charge is conserved. What we started out with is what we end with, and charge cannot be created or destroyed. Then, as we did further experiments, we found out that if you have two negative charges and you brought them closer together, they would repel each other. If you had two positive charges, they would repel each other. If you had two opposite charges, one negative and one positive, they would attract. So we had to try to quantify this force, and we do that with Coulomb's law. The magnitude of Coulomb's law, the magnitude of the force on 1 due to 2 is equal to Coulomb's constant multiplied by the charges divided by r squared, r being the distance from charge 1 to charge 2. Now this equation gives us the magnitude of the force. Well, how do we find the direction? Well, that's pretty simple. If both charges are the same quantity, if they're both negative, then they're going to repel each other, and if they're both positive, they're going to repel each other, and if they're oppositely charged, they're going to attract each other. So, how I read this is the force on 1 due to 2 is going to be directed this way, and the force on 2 due to 1 is going to be directed this way, since both of them are negatively charged. Get a window to the wall. All these problems solved. All these problems.